We have Dr. Jamal here. He's going to actually um, uh, present himself, but Dr. Jamal is actually experienced person. He involved in production, actually chemistry, and I think the majority of the slides will be covered by him, and there will be some detailed also discussion about production chemistry and other topics that might be interested to all of you. So I hope that if you have any question or any inquiry about the topic that is going to be presented, feel free to actually ask Dr. Jamal. Okay. So without further ado, I invite Dr. Jamal. Dr. Jamal, podium is yours.
Thank you, Dr. Mansoor. Assalamualaikum and a very good morning, colleagues and everyone out there. I don't even know, I can't see how many out there actually. The COVID time is over, but we are still online. We take advantage of this online since, me to travel to Johor is going to be another.
I hope we can have you, Dr. Jamal, one trip from KM to JB.
Inshallah. Okay. Dr. Mansoor, thanks to Dr. Mansoor and UTM management for inviting me for the industrial talk. I'm very glad to give this talk. Let me start the presentation. Can you all see the presentation?
Yeah.
There's something blocking here. Hello? There's something blocking my...
Yours what?
There's a small... can you see the slide clearly?
Yes, I can see the slide clearly. How about you, students? Others, can you see the slides?
Yes, sir, we can.
Okay, good. Okay, don't forget others. Okay, we will have also in the last hour we will have a group photo. Okay, don't forget to actually to also have this group photo together. So you need to turn your video on in order to have this group photo. Okay. So I think Dr. Jamal, all of students can see now the slides. So thank you.
Okay, thanks, Dr. Mansoor again. Okay, let us start our morning talk today. It's about fundamentals of petroleum engineering in productions. I believe all of you, as what Dr. Mansoor have explained to me, this is like first year in petroleum engineering fraternity. So I believe more or less you know the overview, like it's not only about production in petroleum engineering, there are reservoir, there are drillings, even economics, there are many more. I am going to just touch on this production aspect of it. Okay. Again, myself is Dr. Jamal. I'm currently a consultant in production chemistry for a few companies. After I'm retired from Petronas in actually this year, basically April this year, I'm retired, and now currently I am helping as a consultant for a few companies. As you can see here, currently it's on Kinetics, Onyx, and Alba Oil. And this is basically me, my basically biography, where I have been so far. Been in the petroleum industry for the past 30 years, basically, all in basically in Petronas. Everything from first year after I graduate, I worked for University Science Malaysia as a research officer for 3 months. before I joined Petronas until I retire this year. Okay, again, I'm a principal in Petronas Production Technologies, production chemist, specialized in flow assurance, production enhancement, and formation damage, whereby I'm very much focused on trying to remove any solids that obstruct the oil from flowing to the surface. Basically, solids like wax, scale, sand. So my job is basically to trying to resolve this issue so that oil can flow to the surface smoothly. In 30 years in production research, but I'm lucky to be in Petronas that I'm able to join the operation as well. Every time we develop some products, we have to go and make sure that it can be applied into the field. It's just not like a desktop study, you keep it. That is why currently we have a lot of joint venture collaboration with universities to bring your products to the field. Okay. Again, I have written like presented. I think I couldn't even count how much presentation have been made, but more than 30 papers, journals, and a few patents, like 3 of them patent. I'm very much into deploying any technology developed from lab to field to the oil industry. As I said, any product that you develop, you go to the field. Okay. Before I go into detail about this production itself, I just wanted to share some of one of basically the technology that I have developed in Petronas. Okay, that is basically the development of solid cleanse technology. Why solid cleanse technology in this particular forum? It is very much related to our production technology. That is why solid cleanse. What is solid cleanse technology? Before knowing what is solid cleanse, the motivation why we develop the solid cleanse is the production aspect of it. Let me try to bring the pointer. Can you see the pointer? This is basically the production system. As you can see, the tubing, the casing.
Dr. Jamal, you click on the actually wrong one. I think you need to choose the pointer another time. Oh, the top one, laser pointer.
Oh, yeah.
Okay, thank you.
Thank you, Dr. Mansoor. That's why it was so small just now. And thanks, Dr. Mansoor. Okay, this is the production system. From the reservoir, from the formation, you wanted to make sure that the crude oil flow to the surface through the tubing, and of course, you can see the casings, the wellhead, the pipeline, and the separator before it goes to the refineries and to the tank before you sell the oil. So this is the production system. Why this solid cleanse technology? Because you can't avoid when crude oil is flowing. You can't avoid this wax and scale or even asphaltene from depositing in the near wellbore formation, or even in the tubing and along the way the wellhead, the pipeline, and into the separator. These solids, wax and scale and asphaltene, blocks the pathway from oil to move to the surface smoothly. That is why this is basically the motivation why we go and develop this solid cleanse technology. Initially, since I am from a subsurface fraternity, my focus was in production. Initially was in production before we diversify the product to the downstream as well. So that is why we developed this technology. Okay, as you can see here, this is basically the formations and reservoir. You can see wax, asphaltene, scale, all this A, B, C, D, E blocking the pathway from crude oil from moving to the surface. If this wax and scale block at the formation, it is the worst case. 70 to 80% of severity if it blocks, because it is too small in DASI terms. Okay, Then when it goes to the tubing, the wax asphaltene can block the pipeline. In fact, you are seeing like half of the pipeline has been blocked with this solid or wax asphaltene, which if your capacity of flowing is 1,000, you are now limited to about only 50%, about 500. So this is very much important to take into account in the production. And what we develop, what is solid cleanse technology? It is the solid deposition. Initially, it was called solid deposition treatment technology at thermochemical to pack system. What this chemical did is it's a two different product. When we combine them, it gives you heat. As you know, wax, in fact, asphaltene can resolve, can be melted due to this heat. And the physical, the chemistry as a byproduct, it is become like an dispersant to prevent this wax from redepositing. In fact, this talk I can give it for like a few days, basically the whole slide, but I'm not going to go detail on this. So just to give you some understanding what can come into this production. Okay. This is just some animation how this SDTT or even solid cleanse works. The chemical treatment, the pre-flush, you inject the pre-flush. Then goes the chemical system. The post-flush to push the thermochemical into the near well bore. You soak it for 24 hours and flow the well. See? When you start resolving the issues in the tubing itself, in the tubing here, as well as in the near wellbore formation, you are basically melting down all the wax asphaltene so that this crude oil can flow smoothly to the surface. When we diversify further, we go into microemulsion acid system to resolve the scale. The first technology was meant for wax. Wax is part of solid. Then we move into acid system for scale, inorganic scale. We include the naphthanates and antifoulant for the downstream part of it. So we evolve from in 2002 up to today. We evolve not only on one product, many other products. So we can now basically resolve not only wax, but it involves asphaltene, scale, and naphthenate. Second, I'm very happy to flash this thing, the robust solid dissolver, to say Dr. Mansoor is one of the developer when he was working with Petronas. So I'm happy to have now currently in UTM. What is a robust solid dissolver is basically within this one chemical, it can resolve both wax and scale. So you don't need to have two different or a few different treatment, but in one treatment, you can resolve both wax and scale. So this is the graph to choose the right formulation to resolve both of the issues, solids issues. Another technology is the novel scale inhibitor. You know that scale is another solid which is depositing in the near well bore. What it does is basically absorbs the near well bore formation here so that you can elongate the production. Normally, when you just use any chemical, it can last for like maybe 6 months, maybe 8 months. Sometimes it's just 3 months. But with this novel scale inhibitor, it inhibits the solid from redepositing, so it can last further for maybe 1 year, 1.5 years, or even 2 years. In our case, in one of our I would say it went up to about 3 years plus. So that was basically the major success using this novel scale inhibitor. And these are basically the evolvement from 2002 up to 2018. What I have explained to you, we diversify from solid cleanse, NSI, RSD. So we evolve, and these are basically the candidates that we have been treating. These are all the wells names: West Lutong, Baram, antifoulant for the surface, Baram again, Bicot. So many treatment using our in-house technology we have deployed into the field. Application, this one I'm just going to browse through. Other fields, you can see 103 barrels of gain, 500, 100. Some of them, you see, not everything is rosy that you can have a success, but we resolve it. But due to other issues like high water cut, we couldn't go into it. But when we do it in the lab, it can resolve all issues of wax, asphaltene, and scale. So these are some of the success story from 2003 up to 2007, and further in 2008 alone, as you can see here, 370, 60. So we have been treating this year by year, being accepted at the field in Petronas. Even for our own research center, we have to justify to our field to go in. So it's not that we are like part of Petronas, we can easily go in. We have to still justify at the field site to get our product in. And this is from 2011 to 2017. We keep trying to sustain this particular technology. And 2018, and this is for the downstream, basically for the cold box in the heat exchangers. Let me not going, for each one of it, we have stories behind it. So not going to go into it, but we have been applying, jumping from upstream to downstream. And this is in the pipeline. Initially, the pipeline is being blocked here, and after using the chemical, it is all clean. Similarly, as you can see here, the barrels jump from 19,000 barrels per day to 32, and from 16 to 32. So it can basically melt this solids deposit to allow it to flow in terms of flow assurance and production. And this is again the left side, it is being cleaned, and this is where it is dirty due to the foulant using the chemicals. And this is the jump in production after using the chemical. This is another Penara A2, again jump in production after we apply the solid cleanse technology. And basically these are the successful technology replication all over Petronas, not only Petronas, in Shell and Exxon as well, in Petronas. These are all the wells that has been applied so far, and some of them are ongoing, and we already going into Indonesia. Probability is that I'm already out, but I'm still getting some news. 3 wells might be deployed this particular year. Okay, that's all about the basically I would say the motivation in production, why I'm very much fascinated or interested in going into this production. People evaluate in reservoir, finding the oil, identify the oil, how much is the oil, but finally when we take the oil out, we are into production. That is why I think production is very much tangible. You can feel it. So now, before I go further, Dr. Mansoor, this is what on the production side of it. Anything you want to add on?
Thank you, Dr. Jamal. Thank you very much for sharing actually the success story with different chemicals, and also with some very useful statistics about application of these chemicals. So for your information, actually, this is for the students. For your information, part one was about actually the motivation, that why production is important. That's why there was a very small part that Dr. Jamal was actually covering. This is about flow assurance and why this kind of operation is important, and how you can actually work towards solving some problems that are some considered bottleneck for the production. That's why I hope that you don't worry. Some of these materials might be difficult, but that was the intent, actually, to bring some motivation for yourself. That's why before going through the normal actually production slides, if you have any questions about the previous slides, any question that you think it's actually can Dr. Jamal answer you, I think feel free to ask it now. Any question?
Yeah, please. In fact, you can ask about RSD to Dr. Mansoor as well.
Okay, I think it's okay. But Dr. Jamal, if you can just highlight why this, what is the difference between application of these chemicals in subsurface and application of these chemicals in surface. So what would be the main differences and similarities that we can have?
Okay, thanks, Dr. Mansoor, for the question. Basically, as you know, these chemicals, when we start developing chemicals to resolve these solids in terms of wax, inorganic scale, asphaltene, naphthenate, there are different type of chemicals. So what happened is, this chemical initially, when it was developed, it was the upstream downhole, which means the chemical, if it is wax, whether it is at the upstream or at downstream, it is going to work, because the chemical was not developed because it is upstream downstream, but it is developed because it is wax, or even inorganic scale, calcium carbonate or barium sulfate. So it should work. But the only difference, I would say, is the application part of it. On the surface, it is easy to identify. You can always collect the sample from the surface, from the separator, from the tank, and analyze it and understand. And basically, you can deploy it much more easily, and in fact, at a more cost effective. And the success rate is almost like 100%, because you basically see the problem issues, you study it in the lab, and then you give the solutions, the chemical. I would say 100% of the time it works. But what happens at the subsurface in the production, sometimes we get the sample, sometimes we don't get the sample. We do analogy what might be the problem, because we don't get the sample. Even if you get the sample that you collect is probably at the depth of 2,000 feet or 4,000 feet. You cannot collect samples along the well everywhere. It is not cost effective. And I'm sure when you start working for the colleagues out there, you are still in first year. When you start working in the field, it's not easy to get the sample. They are very much into production, the field personnel, and when you're asking for samples, the probability for you to get is, your chance is like 50-50. Due to this, for upstream, the application part of it, you have to basically interpret. You have to infer what might be the cause. Is it asphaltene? Is it wax? So in terms of chemical, it should work for both part of it, upstream and downstream. But the application part of it, I can easily tell you that the cost will be a lot higher for the upstream, especially when we are in Malaysia. Everything is offshore, and it even make it even very costlier compared to when you apply this thing at onshore. I hope that answers
Yeah.
Dr. Mansoor.
Yeah, thank you, Dr. Jamal. Thank you.
Any other question that I know for the colleagues out there, maybe some of you already has some some idea about this petroleum industry. You may wanted to just any clarification. Maybe sound sometimes it's silly question, but there's no such a silly question. When we were in first year, I was thinking like, hey, wax. When you're talking about wax deposit in my first year or second year of working, hey, since heat can basically melt the wax. Why are we worried about all these chemicals and things like this? So it's not that straightforward, because when the application part of it, how are you going to deploy this heat into that particular locations? That is going to be a very big challenge to you. And most of the time, heat is going to be uneconomical. So you have to find ways how to resolve these issues, not only in terms of heat, but chemicals and other mechanicals terms. Okay. If there's no question, then I can move forward.
Okay, we can start, Dr. Jamal, the main slides.
Okay, thanks, Dr. Mansoor. Okay, the elements in production. I'll just go through some the introduction and production, the flowing wells, what is artificial lift in terms of production, all three things, requirement of all three things in production, storage and sales of oil, and finally the salt water disposal. So these are some part of it to cover in this particular. There might be production too. There are a few other elements can be covered as well. So we will just kickstart with these elements first. Okay, the production stage is basically, as you know, is the most important stage for us. I'm sure reservoir engineer will go to say, hey, reservoir is much more important. We don't have to argue. Each one of the integrated, and each one of them are important, basically. But finally, for the oil to be produced to the surface, production is it. So production stage is the most important stage when oil is flowing. Whenever gas is being produced. By this time, when you start drilling, all the completions, all the drilling, everything will be taken off. What will be left? What will be left is the casing, tubing, the Christmas tree, or I'm sure you're going to hear a lot more jargons or terms like Christmas tree, like Christmas tree or production trees, and a lot more terms is being used widely in petroleum industry, and basically to make sure that you can flow the oil, you have to regulate the pressure that comes naturally from the reservoir. You have to control so that you can basically decide how much crude oil you want, and allow access to the wellbore in case further completion work is needed. This completion work means just like what solid cleanse or other elements that you wanted to put into the tubing and casing so that you have a smooth flow of this crude oil. From the outlet ward of the production tree, then the flow can be connected to the distribution networks of pipeline. Of course, the first slide that I show you, once it reached the surface, the wellhead, or you can call it Christmas tree or production trees. It goes through the pipeline, it goes through the separators, and finally into refineries, and finally to the vessels and to the sales point, to the oil export terminal. if you have enough pressure in the reservoir, it is easy. Once you start drilling, you put the tubing casing inside, naturally the oil going to be produced to the surface, or it is automatically moving, sorry. Naturally, the production is going to be there if you have enough pressure. But as you know, in time, you are going to have reduced pressure. So you can't produce this crude oil naturally. You need some assistance. That is why you can see the artificial lift and other elements which is required to basically to flow this crude oil. I'm trying to move this thing. Okay. If the pressure depletes, then you have to think about other elements such as artificial lift, so that you can produce them economically. And basically, these are the elements in the production. These are the tubing casing. You call it the wellbore. The oil is coming from the formations or the reservoir. Here, it goes through the casing and tubing. And these are basically what you call overhead, or you can hear a lot of terms, Christmas tree, production trees, before it goes to the separator. The separator, basically the function is to separate oil, gas and water. The oil, water, where it can be transported to the, for our case, transport from the onshore to offshore is another element itself. We call it in terms of flow assurance, and that alone, part of production assurance, which is very much challenging to produce this all these elements, gas, oil, and water to the onshore. And basically, these are all the networks, typical crude oil production train. When you have the production crude oil coming, it goes again. You have seen it just now. The separator. In fact, you have a first stage separator, second stage separator. In reality, you will know later. Or even high pressure separator, low pressure separator, before it goes to the knockout water knockout separator here, where it only remove the clean water out, because we cannot remove if there are some oil or other contaminants involved in the water before you throw into the sea or pump it back into the well. This is the where you have a dilution water pumps here. If you have a water injector, you have to inject water to sustain the pressure. You have the scavenging heat exchanger. The scavenger is basically to remove any bacteria which can cause another type of solid. The bacteria alone is not basically the solid, but it can create solids deposition in the wellbore. That is why you have the scavenging here, heat exchanger, and you have the dehydrator and the first stage desalter. As you see the terms dehydrator, it is basically dehydrates the water from the oil so that you can sell the oil with the right BSNW, base sediment and water. Because if you have the percentage of base sediment water is very high, they are going to buy the crude oil cheaper than what you wanted to sell. So we wanted to make sure that we really clean the oil before it is being sold. Again, salt can cause corrosion. That is why we need to remove the salt as well. Thermal treater, some of them are very much emulsified. The crude oil and water are mixed. It's very difficult to separate using this separator or this water knockout agent. So you need thermal treater in terms of this separator, where you have to separate the emulsified crude oil. So we also need chemicals when you use this demulsifier. So these are the typical, as you can see, even the separator alone, you have many stage of separators, many stage of heaters. So these are the basic networks in this production train. Please just stop me for any clarification. When you have enough pressure, you are not worried about any kind of artificial lift or gas lifting, because of the enough pressure in the formation or reservoir. Once you put the casing and tubing into this reservoir, it can flow on its own independently without any assistance from the gas or even mechanical pumping unit or anything. But how long we are going to sustain this natural flow? Maybe a few years, 2 years, 3 years. In fact, if it is really clean, it can last like 5 years, 6 years. But most of the time, when you start flowing this crude oil naturally, you are going to have a deposition of all these solids, wax, scale, asphaltene. Can you avoid this wax, asphaltene, scale, and naphthenate? A definite no. Why I'm saying definite no? Because most of the it's not most, all the oil, the main elements of hydrocarbon or oil is basically paraffinic, which is hydrocarbons, long chain hydrocarbons, part of the oil. Asphaltene is part of the oil. Scale, in terms of calcium carbonate, barium sulfate, they are part of the oil. In fact, naphthenate, they are part of the oil. So you can't avoid this thing. All these elements will definitely come into picture whenever the situation changes, the condition changes, the temperature, the pressure changes. This is where you are start going to deposit all these solids deposition. That is why this solid deposition and production cannot be separated. You will face it, and as a production technologist or production chemist, you have to face these elements of solids issues. Okay, defined as any well which sufficient pressure in the reservoir. When you have enough sufficient pressure, it will flow naturally. A well which produces oil and gas without any means of artificial lift. Artificial lift means you are injecting gas, or you are putting some additional pumping into the reservoir or into the near well bore. You are going to introduce some kind of pumping from the surface. These are all the artificial lift to produce the oil if there is not enough pressure to flow the crude oil. They require relatively little equipment or expense to bring because of enough pressure. The equipment commonly used consists the tubing, the internal tubing here, the wellhead, or you can call it the hole here is the wellhead or Christmas tree, and of course the casing. On all the other small juggles of accessories, packers, you will know there are many elements involved in the whole production system. Okay, that was the natural flow. Now coming into artificial lift. Artificial lift is a technique used to bring oil from the reservoir to the surface because of decreasing. So when you don't have enough pressure, you have to bring in this artificial lift to produce the crude oil. So how are we going to use, what are the other means of this artificial lift? Mechanical device inside the well, known as pump or velocity string. Pump is basically trying to pressurize to bring the crude oil. Velocity string is basically if you put a smaller string, you can produce it faster because of the interfacial tension. In a smaller string, you can produce it much better and easier compared to a bigger tubing. And also the weight of the crude oil itself and water is going to push down the crude oil from flowing. Artificial lift is also needed in wells when there is insufficient pressure in the reservoir lift the fluid to the surface. It also often used in naturally flow, of course. Sometimes it can flow naturally, but you're only producing like 500. If you just let the reservoir well to flow, it can produce, let's say, for example, 500. But with the assistance of this artificial lift, you may wanted to increase it to 700 and 800. Currently, with the current oil price, which is about 80, 90 dollars per barrel, the more that we got the crude oil from the reservoir, the more income revenue that we are going to get. So we wanted to do that. But as you know, we also have limitation by OPEC. We cannot just produce the oil as we want, even though the capacity is there. We are limited by the OPEC agreement that has been agreed by all over the oil industry in the world. Okay. What are the different type of artificial lift? Beam pumping, submersible pumping, gas lift, and hydraulic pumping. As you can see, most of them are all pumping in terms of mechanical means, and the gas lift is another means. In our industry in Malaysia, by all oil and gas player like Petronas, Exxon, Shell, most of the time we are using gas lift because of the abundance of gas that we have and the easy deployment of this gas lifting in our industry. But as you go to onshore or in different countries, gas lift is not necessarily the main part of gas artificial lift. There are like submersible pumping because of the easiness, because of the logistics. It's not because of whether gas lift is better. Definitely gas lift is better, but because of the logistic, it's cheaper for them to use different kind of artificial lift, especially the beam pumping. Mostly in United States, all of them, probably 90% of it are all onshore. They are going to use beam pumping. For us, we call it like as I said just now, it's like a jargon. They're using donkeys by just pumping to get the oil to the surface. Okay, let me go. I'm sure you or you might have seen documentaries how this oil is being produced. I believe you cannot see this in Malaysia because I think it exists earlier at onshore. The first oil in Sarawak Miri, they were using these are the beam pumping. It is going up and down. I'm sure you have used at home the pumping that you go up and down to pump. It's like a bicycle pump. You go pump the thing to make sure that the oil from the bottom come to the surface. That is basically the mechanism of this beam pumping. Beam pumping in ours, why it is not being used? Because of the footprint itself. What I mean by footprint is basically in onshore, everything must be optimized. There is no space. They just have enough space for all the equipments that is already there. For you to bring this large beam pumping, it's not possible. You cannot even see one of them in the whole Malaysia, Sabah, Sarawak, Semenanjung, anywhere this at offshore because of the footprint. But this is an effective way to produce if it is onshore because these are all just mechanical terms with like 10, 20,000 US dollar, you could already set up one at the gas, at the crude oil facilities to produce the crude oil. Okay, these are the detail if you are really into understanding how it works. For worker, for us as a host, we wanted to make sure that it produce. We have contractors who runs this this is United States, okay, who runs this beam pumping, so that all these elements you will have to know when you are actually operating it. Okay, I'm not going to go in detail on all these terms, the Sakharots, the Sakharots, I just wanted to explain the last one. The Sakharots, when you go up and down, it's like a bicycle pump. You go stroke up and down in the tubing. You basically activate the pump at the bottom so that you can produce the crude oil. So it is a simple mechanism, but for crude oil, because of the safety, you really have to be careful, not just treat this as a bicycle pump, even though the mechanism are the same. Okay, see? At the surface, a large mechanical device called beam pumping unit is attached. This is where you cannot put this at offshore. Why I'm trying to keep mentioning offshore? I believe most of you are going to involve, if you are in Malaysia or most countries, you will be working at offshore. But these are the mechanical device that is located at onshore for you to produce the crude oil. And these are basically the mechanism. This Sakharot going up and down so that you can bring the crude oil to the surface. And if you go detail into all the elements for this beam pumping, you can go through it later. It will be provided to you, I believe. All the elements, how it is. The most important thing is how the mechanism, how it is being produced. Okay, more on this beam pumping. Depends on the size of this pump. It can only produce like 5 to 40 liters of liquid at each stroke. So in a day, probably you'll be producing at max, depend on the size of the pump, okay? But generally speaking, 200, 300, or even for big pumps, it can go 500, 700, 800 barrels per day. But on even if it is like a 10 barrel, it can basically cover the cost of the whole beam pumping. So even 10 barrels or 20 barrels of oil, if they can produce, is good enough for them to basically cover all the manpowers and operation of this beam pumping. And the pump size is not that we can just buy and put the pump. It is determined by the depth and width. We don't want to buy an expensive pump, which can produce 1,000 barrels. If your only capacity is about just 200, so you might just want to. These are some studies that must be done to basically come up with what is the right pumping to optimize the cost. Advantages of beam pumping: high system efficiency. Of course, at onshore, it works very well, cheaper, economical to repair and service. Flexibility, adjust productions through stroke length and speed. You can basically know how much to produce per day based on the limit that you have put. High salvage value for surface unit and downhole equipment. Once being used, you can always reuse again in another well. Of course, the disadvantages is basically the volume. Even our main element in offshore is due to the footprint, but again, at offshore, you can basically, especially in Middle East, definitely it's a no-no because they are producing a lot more than this. So this beam pumping is not possible. Limited to onshore. They already explained here that limited to onshore application, not offshore because of the footprint. Oh, this is Can you all are you all hearing this? Hello?
Dr. Jamal, hearing you?
Yeah. Yeah, but somebody is talking behind it. I think you are talking. I hope you're hearing it.
Yes, clearly we
Oh,
are hearing. I think others also. So others,
okay.
do you have any problem with hearing Dr. Jamal voice?
No. Currently, you are talking in the voice. That's why I'll just let it be. Okay.
Okay, so for others that please mute yourself because I think there are some background noises coming up. So please make sure that your voice is muted, you know. Okay?
Okay.
Okay, thank you, Dr. Jamal.
Thank you, Dr. Mansoor. Done with that presentation just now. I think it has been explained clearly by you yourself just now. Thanks. Okay.
So Jamal, I think we have one or two ESP in Peninsula, right?
Again.
One or two of this completion that one of this ESP installed. I think I remember one time this ESP was going through some workover, right? We have one
Yes,
or
true.
two. Yes.
Currently, I think as by last year, we had two. Not sure if they have any new implementations, but last year we had two. This ESP, electrical submersible pumping, is being used largely in Middle East, but we try to adapt this ESP to our Malaysian, see if it is adaptable to our field. So currently, it is going on testing. If it works well, I think we are going to bring more and more ESP to Malaysian market to produce the crude oil.
I think the main hurdle is sand production because the sand is hurting a lot the component of ESP. That's why, because the majority of actually reservoirs in Malaysia are unconsolidated. Actually, that's why this is. But I think in Sarawak or Sabah, this can be a good choice.
Yes, agree, Dr. So you're right. I believe your years in Petronas really, says everything about it. So for sand production, this you have to be careful when you install. You must make sure that this is the well, if you identify it, is unconsolidated. You have to really choose the right ESP because generally
Dr. Jamal,
speaking.
can you describe unconsolidated sandstone for the audience?
Oh, okay.
Just a simple description about this. Maybe they are interested.
Okay.
Thank you.
Okay, Dr. Mansoor. Consolidated and unconsolidated. What means by consolidated? The sand are very much strong. When you produce all this oil, water is in the sand itself. We don't have a tank down in the reservoir. Basically, it's like a sponge. All this crude oil is within this sponge. When you produce the oil for consolidated, it is very strong, so it will stay intact. This sand part of the formation or reservoir won't be flowing, or very minimum sand will be flowing to the surface if it is consolidated. But if it is unconsolidated, it is like crumble down when you start producing, especially at a high rate, That is why you cannot just produce as you like, even though you can. So this has been calculated, the strength of this formation, so that the sand does not crumble and come to the surface. We don't want it to happen. When sand comes out, the worst part is the erosion. It is going to eat your steel pipeline, steel separator, tubing. It will eat away within year. Within a year, it can take away your tubing. So we don't want this sand to be produced. So for unconsolidated, it's easier for it to come out. For consolidated, it is quite strong. It does not easily comes out. That is what it means by consolidated and unconsolidated. We have studies basically when we got the core flood, the core. We will do a study. How strong is this core? We can basically identify whether with certain number of production, rate of production, whether this core, which consists of sand, going to be come out through the production. So it is very important for you to identify in terms of production whether it is consolidated or unconsolidated. Any question on this consolidated?
Thank you very much, Dr. Jamal, for the clear description of the topic. I hope there will be some interested students that can continue their study toward actually solving this problem. And there are some actually annual competition about coming up with the technology about sand prediction or sand production. So that's why just put it in your mind that this kind of technologies are very important, and of course this will be in line with your motivations and with your future, that you know, you will create the future of your country and you know, of the earth as a whole. So that's why I try to actually think about this kind of issues and problem, and I hope that in the future you will be one of these entrepreneur or you know, inventor for this kind of problem. Okay, thank you, Dr. Jamal.
Exactly, Dr. Mansoor. Hopefully somebody will pick up and, you know, become an expert in this consolidated, unconsolidated. There's a lot of room for improvement. Even though we have been operating for so long, there's always improvement. For us to come up with we tried also using chemicals to make sure that the unconsolidated becomes strong. This chemical goes into the reservoir, and it basically act like a gum to basically attach all this sand together so that it doesn't flow. But at the same time, we must make sure that the pathway to the surface for crude oil to flow is not being blocked. So while you are trying to do something, it can be a bad effect. So everything must be taken into account. These are the few studies that you can focus into when you start going your second year, third year, and fourth year, your internship. You can choose the right thing. There's a lot of rooms in oil and gas industry. Okay, moving on. The artificially submersible pumping here. These are basically examples of this. I'm sure many of you are thinking pumping, how pumps look at the surface. But in reality, for oil and gas industry, this electrical submersible pump, or you can call it ESP, known widely as ESP. This must fit into the tubing. You know how big is the tubing? It can be like only 3 inch. So this pump must be less than 3 inch to fit into the tubing, because it goes to almost to the bottom of the well here, so that you can pump the crude oil to the surface. So because of the difficulties, this pump can easily cost like 20,000-30,000 US dollar or even more for a deeper well. Advantage of electrical submersible pump, ESP, high volume and depth capacity, high efficiency over 1,000 barrels, because we can easily produce using this by electrical means. Low maintenance, minimal surface equipment requirement. Everything is being controlled from the downhole, except the remote, the variable speed controller is only to the surface to control it. Other than that, all the main elements is down here. High resistance to corrosive downhole environment. There are different types, so you must make sure that you choose the right one. Depends on the fluid that is in contact with the ESP. Used in deviated wells and vertical wells with dog legs. Deviated leg wells means vertical means is a straightforward. Deviated means slowly it's going to make a turn, not very immediately, slowly going to make a turn as a deviated well itself, or it can change to horizontal wells. Disadvantage, poor ability to pump sand. So this is where I think when sand comes into picture, there are currently new latest development, but still not proven, because as I said, if a tubing, it can a steel tubing, this flow of sand can erode the tubing easily. Okay, that is basically first I talked about the beam pumping or the donkeys. Second, we talk about the ESP, electrical submersible pump. Now we are going to move into gas lift. Before we move to gas lift, any questions for the beam pumping and ESP? If not, let's move into our third main of this gas lift, artificial lift, which is gas lift. Why gas lift? A series of devices called gas lift valve inserted in the tubing. Gas is injected into the well. Okay, let me just explain how this gas lift work. Gas is injected through the casing. Gas is injected through the casing, and you have gas lift valve such as this. And it is not only in a single place. It can be at several places, like even 3, 4, 5, 6 different gas lift at different location at different depth. And this all has been calculated at what depth we are going to inject the gas. Depends on the crude oil that is in the tubing flowing from the producing formation or reservoir. So simply put it this way, why gas lift? Gas is going to make the crude oil lighter in the tubing. When it is lighter, you can produce the crude oil from the surface much easier, because that is not much of hydrostatic pressure that is pushing downward. So with gas, it is much easier. It is much lighter to produce the crude oil. So the fluid in the tubing is made lighter by the gas, and as a result, the mix is pushed to the surface by reservoir pressure. In fact, the reservoir pressure is there, but it is just not enough. So with gas lifting, you can basically maximize the flow, and it is just not by injecting gas. It also must be calculated at what rate it must be injected for each well which is flowing at a different rate. Artificial again, gas lift. Let's see on the nice picture over here. The tubing here, the casing. Tubing is internal tubing. The casing, I would say the outside tubing. And in this particular case, it just shows that there is a gas lift valve here. Even though there is enough, there is pressure from the reservoir, but probably it is only producing about 100 or 200 barrels per day with the current pressure. But with the gas lift inserted here, and enough gas amount, probably you can jump from 200 to 500 if there is enough gas is being inserted into the tubing. These are the produced fluids which is coming from the tubing. Gas lift here is injected through one of the valve which goes into the casing or the tubing that's surrounding the main casing, main casing. And these are the schematic, as you can see here. They are showing you in a different diagrams for you to understand better. Again, gas lift. When we can actually use the gas lift, source of gas, compression equipment is required for gas lift. First of all is the gas. If there's no gas surrounding the well, you can't use the gas. For you basically to bring gas on your own to offshore, it will be very uneconomical. So whatever that gas that is being produced by other wells, which has abundance of gas, can be used for another well that require the gas lift. Proper installation and compatibility of gas lift equipment surface and in wellbore. Okay, this is quite normal for any gas lift. They are not, it's just not like pumping. There's a lot of elements, device that need to be inserted. Advantage of gas lift. Gas lift is an artificial lift process that closely resembles the natural flow process. It is just natural flow, but it is basically reducing the hydrostatic pressure. It is making the crude oil lighter so that you can produce the crude oil more than what it can flow naturally. You can add more revenue to your company by having this gas lift. Disadvantage of gas lift, of course, the first one, if there is no gas present, it is not possible. High initial capital purchase cost, yes, the initial, but once it is already in operation, the cost is quite optimum. It can be used. Maintenance intensive. It must be maintained at all time. Get the gas lift valve and all the devices. Difficult to operate nowadays with the new technologies. It is becoming very common. So I won't say it is going to be difficult. It is just like any other artificial lift. But initially, yes, it was difficult to operate, to understand the amount of gas that need to be injected. But with our development of technology, it is already part of artificial lift. It is being used largely in, especially in our own Malaysian field. Okay, these are very much similar drawings. Side pocket mandrel with gas lift. It is not only one, as you can see here. As I said just now, it can go even 5 of them. 1, 2, 3. So when the gas is injected through here, it goes to the side pocket over here or through the casing, and it will ignite the flow of this crude oil at this point, for this particular well, so that you can flow the crude oil at a much better rate. And basically the gas lift, these are typical diagrams, basic components for the gas lift. It's just not like a pump and some hoses to inject the gas, but these are all the different devices that you need. The main elements is basically here where the gas lift installation. You have to have a gas. Where the gas is coming from? It is coming from the additional well which has abundance of gas. You can flow through here and you can produce it back into this separator and storage facilities. And as much as possible, why you have all these regulators and separators, as much as possible, you're trying to capture this gas and try to reuse it to inject back into the well. Gas that can be abundant of gas, some of them being injected into another well, because due to our limitation even to flare the gas, we are not allowed to just flare gases beyond certain limits. This is where we have another responsibility to find wells where we can inject the gas back into the reservoir. So all these plays roles when the gas, when the production comes out, the gas comes out, we wanted to treat the gas, whether we wanted to treat it back into the same well or we wanted to inject to another well, high pressure gas. Well, if this is another well that is coming to give you the gas to inject into this gas lift well. This is the fourth one, hydraulic pumping. The concept again, whenever you use pump, you try to bring, you just trying to pressurize the oil so that you can get the oil out from the reservoir to the surface. At the bottom of the well, the powered oil enters. You basically use this hydraulic pumping to pump oil into it. Okay, this is a powered oil, not crude oil itself, which can be separated later, so that you can bring the crude oil to the surface. Again, this pump is located inside here. So similar to ESP pumping, which goes very much below, you can also use this hydraulic pumping to, hold on, again, hydraulic pumping to bring the crude oil to the surface. Okay, advantage of this hydraulic pump, no moving parts, all the parts is within the pump itself. The moving parts is all within, it's not outside the pump itself. High volume capability, it can produce a lot more compared to gas, even though most of the time we are using gas because of the availability of this gas. Multi-well production from single package, low pump maintenance. Normally when you start using this kind of pump, it is meant for like 10 years, or you have very minimum maintenance. Again, the disadvantage, of course, for you to justify why you need this hydraulic pumping, because the cost is quite high. Definitely your boss or your manager wanted to know why you wanted to use this. Why don't you go for other means? This is quite expensive. So if there's enough production that can be produced from the well, you can easily justify the need for this hydraulic pumping. If not, you will have hard time, because when it comes into the field in the real terms, it is all about money. If your ROI is enough to make use of this hydraulic pumping, go for it. If not, however good it is, you can produce, but if it is costly, it is very difficult to get this hydraulic pumping into the field. Okay, just now, they are all the different kind of artificial lift. There are 4 of them: gas lift, beam pumping, hydraulic pumping, and ESP. Any question for this different artificial pumping before we move to the next topic, which is oil treatment, oil treating?
Assalamualaikum, Doctor. I want to ask
Waalaikumsalam.
question.
Okay.
Which one
Your,
the mostly used in
can you,
Malaysia?
sorry, even though I don't see you, can you identify your name, please?
My name is Mohamad Iman.
Oh, okay, Iman, okay.
Okay, my question
This
is, which one of the artificial lift is mostly used in Malaysia and why?
artificial lift, is the gas lift is the one mostly being used. First, because we have enough gas from the other high pressure wells. First, second, because of the other pumping unit, they are not feasible at all, such as beam pumping. Definite no, because of the footprint, and others like ESP, as what I explained earlier, the only two of them is being tested currently. As you know, many wells in our old wells have unconsolidated sand, so sand is not good for ESP, and hydraulic pumping is quite expensive. It can be used, but it is quite expensive. So these are the purpose why gas lift is the main one that is being used in Malaysia.
Thank you, Doctor.
You 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 got it?
Yeah, yes. Thank you, Doctor.
Okay. Okay. Hope it answers you. Any others? Okay. Dr. Mansoor, want to add anything before I move to
Thank
all
you.
three thing and
I
next
think
subject?
this topic is okay, Doctor. We have a question from one of the students. He said, "Hello, Doctor. What is the meaning of footprint in beam pumping?"
Oh, okay. Thanks, Dr. Mansoor. Okay, that's why it's good that sometimes Dr. Mansoor highlight me to explain about consolidated because we use these terms like as though everybody knows about it. Footprint is basically the size of that beam pumping. Is how big footprint is basically we call it footprint. Is our terms, but in a layman term is how big is the pump. If the footprint is big, means how big is the pumping unit and how big is the total equipment would fit into the offshore environment. So footprint means how big it is. Onshore or offshore will not allow you to bring in. Offshore has been designed to just fit their main equipments, and of course they have some allowance for to bring in some equipment, but they don't have enough space to bring in anything. Of course, definite no for this beam pumping because it is quite big and heavy to fit that into the onshore. So that's what it mean by footprint in relation to this beam pumping.
Yeah, I
So
think
it is big.
this is the same. This is I think Dr. Jamal. This one also can be. This question also is somehow related to the previous question, and that's why in Malaysian field there are actually less application of others such as this actually pumping units that is required a lot of space. That's why in the current platform that we have, they are very actually small and cannot actually accommodate for further equipment. So that's why, yes, I think this is a good question. Thank you. Thank you, Tilgan.
Thank you. I hope it answers. So footprint, how big is the size? Big, heavy, no for our Malaysian offshore platforms. Okay. Okay, you can always post the question later through through the through our written written platform here.
Yeah.
Okay.
So
Let me move into this all treating. What it means by all treating? Simply put it this way, the oil that we produce from the reservoir is really black oil. You cannot inject, you cannot put this oil into your car directly, or even to be sold out there from the reservoir. For you to put into your car, it goes through a lot of process. But in fact, even before you bring that to the sales point, it must go through a lot of oil treatment so that the oil that is being sold to our to our whoever is purchasing, they have the clean oil. What it means by clean oil, you will go through the presentation after this. So generally what comes out of the well is a mixture of oil, water, gas, and even sand, of course, for the mostly in Malaysia now, 20, 30 years of operation, sand is quite common. Foreign materials such as water and sand must be separated. You cannot sell this water and sand together. If you sell together, if you are selling it at 80 barrels per day, they will be asking for 40 barrels per day, $40 barrels per day. So it's best for you to get this water, sand out of the oil before you sell so that you can maximize your revenue to the company. This process of removing water, sand is also known as oil treating or oil dehydration. Dehydration is basically you remove the water, in which water is removed from the oil. The amount of this foreign material is referred to as BSNW, basic sediment and water, BSNW. Before you sell one of the element that they measure is BSNW. If your BSNW is in this particular written statement is 1%, you must make sure that BSNW is 1% and below. If it is more, you will be penalized, or you will have to sell the crude oil cheaper than what it is at the market. In fact, in Petronas, it is 0.5. In Malaysia, I would say for the environment, probably it is 1%. But when it goes into selling, it is 0.5% BSNW before the oil can be accepted at a sales point. Basic type of equipment used for oil treatments are separator, free water knockout agent, free water knockout, and heater treater. Okay, these are the main three. Separator. By the means of separator, you already know it's when the crude oil which comes together with water, it goes to the surface and into this separator here. It must be separated. Water must be separated. It is taken down here, and oil here, and gas here. We're not going to explain here whether oil goes after this, or gas, or water, whether the water goes back into the well or being recycled or being thrown overboard it back to the sea. Even for you to throw this water to the sea, it has specification. You cannot just take this water and throw into the sea, even though you are just in the middle of the sea. You will be penalized by our DOE. If the water contains oil dispersed, Petronas will be penalized. So it's not easy for you to even inject this water back to the well. It is not going to be easy. It has certain spec. What is the water spec that you can inject back into the well? So see, these are basically the separator is a large pressure vessel designed to separate production fluids into their constituents components, water, oil, and gas. Separator utilize of course the mechanism that is being used is basically mainly gravity, but with the advance of technology, they have a cyclone, they have different type of design of these separators. How you separate this oil, water, and gas. The oil, which is heavier than gas, falls to the bottom here because, naturally oil goes down and gas goes to the top. Major components of the separator: primary separation device section, gravity settling separator section, mist extractor to remove small particles. If I were to go back here, it doesn't have, but these are basically the separators to remove, oil, water, and you have another plates over here, basically where it goes, the natural gas is being treated for that, so that it goes to the top, other than its natural gravity settling. So initial the process, initial separations, gravity separation, mist extractor is basically, as you can see, remove small particles from the gas. Again, everything, not only oil, not only water and gas as well. Each one of them, when it is being separated, it is not totally clean, and it can be used directly or it can be sold directly. It goes through a process again to throw, even to throw the water out. You have specs, or DOE is going to kill you, is going to charge you. Even for you to inject the well into the well, it has its own spec. For the oil to be sold, you must make sure there's not enough water content. You have to remove the water. Even for the gas to be sold, if it has contaminants like H2S, you must remove the gas first. So every single elements, gas, water, and oil, it need to be treated before. It's not only oil, even though our main elements is oil, because oil is money. But due to water and gas, it is going to cost us, which is going to take our revenue away. Okay. What are the type of separator? Horizontal separator, vertical separator, spherical separator, comes in different diameters. This all will be an economical evaluation will be done, which is the right separator. Also on technical basis, if you have a lot of gas, of course, you need a vertical separator better than horizontal separator. Why you need spherical separator? They all have its purpose. Which one need to be designed or bought to be used for each particular field. Classification by function, two-phase separator and basically the three-phase separator. What is two-phase separator? Two-phase separator is just separate the liquid and the gas. The gas is gas. The liquid might contains water and oil. So in a two-phase separator, it only does separate the liquid and the oil. It doesn't separate the liquid into water and oil. But for three-phase separator, it can separate all gas, water, and oil at the separator itself. For our very old platform, mostly they are two-phase separator. They just separate the gas and liquid. The liquid is being flowed to the onshore, maybe 40 kilometers, maybe 30 kilometers, maybe 100 kilometers. You are flowing both liquid and liquid which contains water and oil. Is that good? Because when you flow water together with oil, it takes place of the oil. It is very uneconomical. This is where the three-phase separator come into picture. You wanted to separate the liquid into water and oil so that you can dump the liquid, the water into the sea or pump back into the another well. So you only flow crude oil with very minimum water content in it. So you can maximize the revenue having this three-phase separator. So these are all, whether it is two-surface, currently everything we know about this two-surface and three-phase, and economical judgment and the technical judgment will be done what kind of oil is flowing. So two-phase or three-phase separator will be introduced. Monotube horizontal separator. Again, the liquid is here. The gas will go to the top, and this mist extractor here basically take away the contaminants from the gas before you sell the crude oil or you flow the gas to a pipeline to the sales point. Similar, the liquid in this particular case, the liquid goes as water and oil together. You are not separating the oil and water at that platform or at that separator itself, but it goes to another stage before it being separated. Monotube horizontal separator. Again, in this particular case, as you can see here, it is a three-phase separator. You have water can be separated out already. Hello? Hello?
Yes, Dr. Jamal, we're having you.
Oh, okay. I thought, sorry, I thought somebody interfering. I can continue?
Yes, please.
Okay. You have these are three-phase separator. Water, oil, and gas is being separated at the separator itself. So you can dump the water and you can just flow. You don't need water to be transported to the terminal at onshore. We need oil. Similarly, you have oil, water, and gas in a three-phase separator. These are, yeah. Basically, these are the schematic diagram of how the dual tube horizontal separator for the inlet stream, and you have all sort of devices over here. The main elements is again the gas is out, is being separated, and the liquid is being separated here. So and both of these are basically the it's a two-phase separator, but you have two. Why we need two most of the time? If the first one, we know the type of crude oil that is flowing, it is going to be difficult to separate. This is where you need a dual tube. So you go to another from here. I'm just giving an example why we need two. From this separator, it goes to the next separator to make it more efficient, so that the gas that is being produced are much cleaner compared to the first separator. These are the type of vertical separator. Most of the time when it is for the condensate or very lean crude oil, you'll be using vertical separator, so that you can easily separate this gas and liquid or oil in the separator itself before you separate this both to the out to the pipeline or to the sales point. So why it works on similar concept, but depends on the type of crude oil that is coming in into the separator. You can make judgment whether it should be a horizontal separator or vertical separator. If it is a lean oil, it's better to use the vertical separator. These are the schematic diagram of the vertical separator. These are the two-phase and also the three-phase. This is a little more complicated because you need to separate the water and oil as well compared to the and gas. For two-phase, you just have the gas and the liquid. It's much easier mechanism. It's cheaper compared to the three-phase separator. It's not about cheaper, but whether you really need the three-phase separator at certain field. Same concept again. For horizontal, vertical, and spherical separator, you just wanted to get this gas, separate the gas and liquid. Okay. Just now, when for the all treating, we have three type of devices, which is the separator, the free water knockout, and the heater treater. The other three. Though this is the second one. So any question on the separator itself? Okay. Let me move to the free water knockout. We used to separate oil, water, and gas. Well, actually, it is very much similar to the separator. It is very much similar to the water separator, but in this particular case, you wanted to get rid of the water out of the separator. This mixture flows into the vessel through as usual, similar to a separator inlet valve, and then allowed to slow down in the large settling chamber, similar to separator. Any free water mixed with the oil settles to the bottom, oil is removed through the separator line, and gas which rises to the top is extracted. Again, this is what I said just now. It is very identical to the separator, but it is being called free water knockout because it is eliminate only free water, not water which has been emulsified, water which has contaminants. So water which has contaminants must go through a separator rather than this free water knockout. So only free water. So you can dump to the sea or pump back into any requirement of need of any wells which need water to sustain their pressure. Okay. The oil and water outlets are controlled by level control valve, which prevent the vessel from draining completely, keep the gas trapped into the top of the vessel. So over here, the water is basically totally cleaned before you can remove the water. Most of the time they will be using, most of the time, not all the time, they'll be using chemicals as well to make sure that the water is totally free of any contaminants, so that the oil dispersed, the oil in water contents is another, if I'm not mistaken, there are some oil dispersed into the oil. If the oil is lower than 40 part per million, it is basically okay to throw overboard. If it is more than that, you cannot. You have to treat them again as long as it is below 40 ppm to throw them overboard. As you can see here, typical separator. These are the typical separator mechanism. Typical. It is just has elements for chemical injection. This is vertical and this is horizontal for chemical injection, so that you can get rid of water, clean water below 40 part per million and other contaminants if there is any. Now comes the third device, which is the heater treater. Again, why heater treater? You have elements to heat the inside the separator. Why we need heat this time? If it is a lot more difficult to separate this oil and water, you need a separator that has the facilities of this heater, so that with heat, emulsified fluid can be separated easily. Sometimes even without any chemicals, with heat alone, you can separate the emulsified fluid too, so that you can only have water and oil separately. So that is why we need a heater treater. But as you can see here, we hope we don't have this kind of emulsified fluid, because the cost of this heater treater is more expensive. For our to optimize the cost, we see whether we need this heater treater separator, or we can just make use of any chemicals to de-emulsify the emulsified fluid. So any emulsion, you have to have this. If not, try to use normal separator but with some chemicals, so that you have a clean water. Similar to free water knockout, but the treater has been heated capability, inclusion of fire tubes here. Yeah, you just have an heating elements. The combustion of gas within the fire tube is used to heat oil and gas. There are mechanisms of the heater treater. As the oil and water mixture grows hotter, the emulsion breaks and forms into clean oil and water. These are the mechanism. Any emulsion, when you start working to going to the field, if you have emulsified, first thing you can do is trying to heat them. If you can separate them, you don't need any chemicals. Beyond that, it is all about economics, whether you need the heater or you can just put another chemicals which is cheaper than the heating. Water is removed from the bottom and sent to the water disposal system. The clean oil is drawn of the center of the vessels, sent to the oil storage. Of course, the oil and after the oil and water is being separated, any natural gas in oil water emulsion exits at the top of the heater. This is like a three-phase separator. You have oil, water, and gas. Typical heater treater, similar to the separator and free water knockout, except it has the heating elements over here. So with heating elements, if it is, you already judge that you have this heater treater, you already optimize the fluid, separate the water and oil into different phases rather than having emulsified fluid. So if there were to be still any emulsified fluid, even after heater treater, you introduce chemicals. You introduce small amount of chemicals, but maybe without the heater treater, you need big amount of chemicals. So whichever is economical, whether you have to go through the heater treater or both heater treater and chemical with optimum cost. Combinations, a typical combination of equipment is shown below. Oil, water, this is the wells, oil, water, gas going into the free water knockout separator. Gas goes up and the water goes down. And you have emulsion as well here. So when you have emulsion which cannot be separated over here, this emulsion goes to another heater treater here, which basically demulsify the emulsion into water and clean oil. See, the clean oil goes here, we go to the storage and sales, and the water is being cycled back and being disposed into well after, of course, after it is being treated. These are the typical oil treating facilities. Incoming production stream here. This is coming from the production or the well itself. It goes to the gas separator. The gas, this is just schematic. The gas also goes through processes before it goes to the gas compressor. And the water, or even I would say liquid, goes into the free water knockout. Here, the gas again goes to the same process, and the water goes for disposal. And what is this? These are basically the emulsified fluid, or which contains water and oil. Water and oil. It goes through the heater treater. Again, the gas goes to the top, and water goes to the bottom here, to the skim tank, and then it goes through process, whether you want to pump it back to the well, throw overboard, or whether you wanted to clean it for different purposes. But the oil goes to the tank, to the terminal. This is where the BSNW will be measured to make sure that it is below 0.5%. for it to be sold at optimum price. Okay, once you already treat the well, finally it is all storage and sales. I'm trying to put it into onshore and offshore. At onshore, it is easier. The clean oil from the treater. You have the oil storage tank. I believe during your orientations, if you have the chance, at least, you know, join with the SPE, you know, you have a visit to their oil storage tank. It is very massive. It's big. It can contains like a few 100,000 barrels, like 400,000 barrels or 500,000 barrels per tank. You can store them into a storage tank, and finally to the sales point, because this is onshore. So you might be just using the truck for sales, or you go through the LACT unit where the BSNW is being measured before it's being sold. Of course, the bad oil, I won't say it's a bad oil. It is emulsified crude or emulsion fluid. It goes to the heater treater before it is being sold out there. This is for onshore. For offshore, offshore production platform can sometimes be equipped with oil storage, but most of the time you can see there is no oil storage equipment at the platform. I'm not sure if it is shallow water is fine, because shallow water is like 70 meters, 80 meters, less than that. You can still have leg platform to put a storage tank. But believe me, most of the time it will be transported to the onshore to store the crude oil. The clean oil can be sold through the pipeline, direct to the, extending the platform from sea floor to the land. This is basically going to the terminal at onshore. Again, offshore, for shallow water is fine. It's much, it's a little bit more, much easier. But when you are talking about deep water operation, there are different means how oil is being shipped through a pipeline along the sea floor to another storage platform in shallow water, or to onshore. Sometimes storage platform not necessary, and the oil is shipped directly into the sales point. Most of the time, actually, storage platform is I think would be much economical for the oil to be transported to the onshore if it is already shallow water. For remote oil field, deep water location, and small oil field, where seabed pipelines are not cost effective, the use of floating production storage for FPSO, floating production storage and offloading, is a good option. If the platform is located 200 kilometers away from onshore, for you to build pipelines 200 kilometers to onshore, if you don't see the economics of it, definitely they won't put a pipeline. They would rather go for the option of FPSO, floating production storage and offloading. It is like a ship, big ship, just to store the crude oil. It's just go nearby, and they have all the host to pump the crude oil to the FPSO. And then FPSO can basically move, so it can move to near to the onshore and offloaded to the tanker. These are just some schematics. This is the FPSO. These are basically the drilling platform where you drill and put the crude oil is coming to the surface before it is being transported from the platform to FPSO to store the crude oil. At the same time, this is just some schematic diagram where you don't even have platform. These are all like a subsea existing well center down there. Because of the deep water, it is not economical for you to build a legged platform. It is better off to make use of these subsea facilities, well centers facilities over here to produce the oil straight to FPSO. This is giving you a better description of this FPSO. What is FPSO? This is FPSO, and once all the oils is being transported into this FPSO, then it will be moved to another tanker who is buying the crude oil, or this FPSO can move to onshore to transport the crude oil to the onshore or tank. This is giving you a feel of how the deep water. This might be very deep into the well. For you to put a platform is not a good option. No, it's not economical. All these well centers in the deep water is being installed. The oil is flowing direct from here to FPSO or to a small tank before it is being sold to or brought to the onshore. Before even you sell the crude oil to the sales point, to prevent environment pollution, the water produced must be re-injected into the ground, often into the same rock from which it is drawn. The water sometimes is not possible to be thrown overboard to the sea. So you treat them, you re-inject them back to the same well or to another well. But it must be treated because once you salt water can again cause solids deposition in the formation. The water is taken from oil processing equipment and usually sent to storage tank until sufficient volume has been accumulated. Often in offshore operation, the salt water from wells can be disposed of into the sea itself after it is being treated. You cannot just throw off this untreated water. Okay, however, the water must first be sent through several cleaning devices which remove any traces of oil. Again, for the gas treating, we talk about oil treating just now. We talk about water treatment. Even though you don't need the water, even for you to throw the water, you have to treat them. Now, for the gas treating, natural gas consists of various components which are present in different concentration, water and impurities. Reason for treating to meet sales spec, they don't want too much carbon dioxide inside that gas. If you have too much CO2 as well as H2S, in other terms that you use when you have too much H2S is sour gas or sour oil. When you have too much of H2S, your oil become cheaper. It is not safe to in fact inject this back into the well as well. So you must treat this gas before it is being sold. At the same time, excessive gas can also cause hydrate formation. Hydrate formation is basically like an ice cube. Ice cube that can block the crude oil or gas from coming out from the reservoir or formation. So even this you have to treat to prevent this hydrate formation. What it means by gas sweetening processes, more terms that you are going to learn. Gas sweetening is basically removing H2S. That's it. When you have gas, H2S in a gas, it is being called sour gas. So when you remove this H2S from the gas, it is called gas sweetening. It is becoming, the quality of the gas become better. It is much expensive compared to sour gas. So that is what it called by gas sweetening. Is the most common gas treating process, also known as amine gas treating. Amine is the elements that is being used basically to absorb this H2S. That is why it's being called amine treating. It goes into two unit, absorber and regenerator. In absorber, the amine solution absorbs H2S and CO2 from the upflowing sour gas. Sour gas is when it contains this H2S, especially H2S, to produce a sweetened gas stream without H2S or less amount of H2S. As a product, an amine solution rich is being absorbed into the acid gas. It's basically this regenerator means it is trying to recycle this amine. Amine is expensive, so amine used can be recycled so that the same amine can be used into the absorber again to absorb the H2S. That's what it called the regenerator or a stripper. Gas sweetening process. The sweet gas normally goes to additional process, dehydration, hydrocarbon recovery. The acid gas contains most of the CO2 and sulfur, which is H2S, either flat or sent to cloud sulfur recovery unit. So in a sour gas, it contains all these things. Just giving one example, C1, carbon number 1, 2, 3, 4, propane, methane, butane, all these part of hydrocarbons that is part of the crude oil. And you have nitrogen, you have hydrogen sulfide, CO2, all these other elements. And these elements contains H2S and CO2 is being called sour gas. Going through this, the sweet residues which has been cleaned can be basically goes to the sales point, but which still contaminated goes to a gas acid gas removal. So acid gas is being removed here. Whether there are many technologies currently ongoing, whether we can basically recycle this H2S or re-inject back to the well. Okay, again, gas sweetening processes. This is the absorber that absorbs H2N and CO2. Is the regenerator. The amine that is being used in the absorber can be reproduced back in the generator and recycled back into this absorber to be used again. Right. And we have, I think we are almost at the end, I think. Oh yeah. I think we are missing slide of the, thank you. Sorry for that.
Thank you very much, Dr. Jamal, for this great presentation. This presentation was mixed with actually experience, knowledge, and you know, so that's why I hope I would like to actually greatly thank you for your time. I know you are very busy actually, but you've accepted our request, and I hope you can also continue again for you know, joining you know, UTM for more actually in-depth knowledge sharing about your experience. Before we go, Dr. Jamal, for the group photo, I just would like to ask students if they have any question about the topic that we have. Okay, any question? Okay, so that's it. I think there is no question. I think that's okay. So let's turn on your. I think you can actually close actually the sharing, Dr. Jamal. Is it possible?
Oh, okay. Hold on. I'm trying to figure out.
Okay, great,
Okay.
great. Okay,
Okay.
okay. Thank you, Dr. Jamal. So please, all of you, turn your video on for a group photo. Oh, 4 of you are there. Ashley. Good, good. Okay, okay, great.
Okay, great.
Oh, also we have another team, our group, you know, Danish, Daniel. Oh, good, good, great. Okay. Oh, also we have, you see others. Oh, Damia also, she has with another one. Oh, okay, great, great. Oh, okay, okay. We have Shahida also. That's nice. Oh, Damia with more than one. Oh, okay, okay. We have Ani also Noor. Oh, great, great. We have also 2% with a dot. I don't know, but in the future, I think you need to include your name. Okay, Aaron also. Okay, Aaron Yap and others also. Okay, I think let me have a group photo. Can thumbs up for this group photo. Okay, 1, 2, 3. Okay, one moment. I save as. Okay. 1, 2. Let's go for the second actually picture group photo. Okay. In 1, Amirul, Ashley, Masruf. Okay, 1, 2, 3. Okay, great, great. Okay, thank you, thank you. I think there will be more actually sessions for us to actually invite this knowledgeable people actually to help us toward gaining our you know, our target, our objectives in all courses. So I think that's it. Thank you very much for all of you, my students, and also Dr. Jamal, my dear friend, and also ex-colleague. And I hope I can see you soon, you know.
Inshallah, inshallah. All
We
the
go
best.
for the, what was our meal, you know, together?
Favorite tandoori chicken again.
Okay. Great, great. Thank you very much, Dr. Jamal. Thank you very much, all of
Thank
you.
you.
See you in the near future, inshallah.
Inshallah.
Assalamu
All the
alaikum wa
best.
rahmatullahi wa barakatuh.
All the best to you all.
All the
Thank
best.
you.
Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Doctor.
Thank you, Doctor.
Thank you, Doctor.